Good morning, my lovely 12s. Right, buddies, we've done it. We've finished our first mechanics unit. This is it. This is the final revision lesson of our kinematics unit, the very first one. So for today, the title is just Tricky Suvat Practice Day. And what I'm going to show you is I'm going to try to, well, I found this question, which is an absolute nightmare question. I'm going to do this one question with you, and we're going to try to work it out together. It's really, really quite tricky, and you're going to have to really kind of put your mechanics skills, but also your math skills to the test with it. Then I'm going to give you the vast majority of this period just to practice from the mixed exercises at the back of the chapter, because as you know, that's where all the hardest exam-y questions are, and I'm going to encourage you to go and try a whole bunch of really hard ones of those. But first, let's do this horrendous, very difficult, exciting, amazing, but really tricky question. Are you ready? I am. Let's do it. Okay. So this is hard because it involves two objects. I'll show you what I mean. The ball A falls vertically from rest from the top of it. Okay, from rest, should have highlighted that too. From a tower which is 63 meters high. At the same time as A begins to fall, another ball, which is B, is projected vertically upwards from the bottom of the tower. Now, it starts at the speed of 21 meters per second. Now, here's why it's hard. The balls collide. Find the distance of the point where the balls collide from the bottom of the tower. Okay, this question's tricky, but it's not too bad. What do you think we should do first? Well, if you said lay out the gibbons and do Suvat, I'd normally be with you, but it's a pretty tricky question and it would benefit from something. It would benefit from a picture, right? If all this motion is happening, I think we definitely need a picture. So here we go. I'm going to start with a picture and I'm going to do Suvat after that. So here we go. Here's what we got. First things first, we've got ball A up here. And ball A is falling downward and it starts at rest, okay? So it starts at 0 meters per second. Cool? What else do we know? We know that ball B is starting at the floor and it's going to go up like that. It's ball B and it goes up at 21 meters per second. Cool? What other information? Oh yeah, it says the tower is 63 meters tall. So 63 meters is the height of the whole tower. And that's pretty much all it tells us. Okay, so right on to the green then. I'm going to start reading from the green now. So I've done the yellow, I've done the blue. From the green, the balls collide. Find the distance of the point where the balls collide from the bottom of the tower. Now, this is where it gets a little bit sneaky, my buddies. It's a bit wily, this. But let's just draw any old spot like that. And I'm going to call that just, I don't know, P for the point where they collide. It's not important, though. Now, here's the thing, my buddies. This how do I explain this to you really nicely? I find this a bit tricky to explain this, but I'll have a go. We don't know how far up P is, okay? So here's what we do know, though. For sure, it's a certain distance of the way up from B. Now, what I'm going to say is I want to call it X, and then I'll have to call the other one Y, though. Yeah, I'm going to anyway. Okay, here's what I'm going to say. The height that this goes up to is going to be x, okay? Actually, no, I'm going to be physicsy. I'm going to call this height S1, even though it's funny, okay? Because you know we're talking about displacement, right? This can be called S1, okay? That's the first displacement. Now, this one here, the height that it goes down to here is going to be S2, okay? So there's a certain height there. Now, what do you notice about S1 and S2 when you add them together? Yeah, that's it. They equal to 63, so that covers the entire cliff. Now, that might be key in a minute. Now, here we go. I'm going to do my best to explain this right, and I bet you I explain it perfectly in the first go. Well, fingers crossed anyway. Watch me have to explain it 3 times in this video, but I'm going to do my best. Okay. There's a funny trick to this, my buddies, and to know this trick, we're going to have we're going to have 2 balls crashing into each other, okay? Now, here's the funny thing that you have to know about when 2 things crash into each other. If something collides, what it means is it's occupying the same space in the same time. Okay? If you imagined 2 cars on the road and one of them stopped and the other one ran into the back, it's because what happened was at the same time, at that one particular minute, the one crashed into the other because the one had stopped and was occupying that space, and the one that was moving also occupied that space, therefore they crashed. Cool beans? If one of them stopped and then left again, and then another one drove in that same spot, they wouldn't hit each other because it wasn't in the same time. If one of them stopped and if one of them was stopped and another one stopped short of it, they wouldn't have crashed into each other because they weren't occupying the same space. So that's going to become clear in a sec. But yeah, you just need to know that. In order for something to crash, it has to be occupying the same space in the same time. Now, here's what I'm going to do, my buddies. We're after this distance. We're actually after S1, okay? That's the answer to the question because it says find the distance from the bottom of the tower. So S1 is the answer to the whole question. Now, here's what we're going to do. Let's start off. I'm going to consider ball B first because ball B seems to be the one that's linked to the final answer because it's linked to S1. So let's do it. Ball B. Now we're going to do our suvat to find a direction to be positive. I'm going to just say up. I just picked up because it's going up, so I chose up. Suvat. And you guys know already that the direction convention doesn't matter. As long as you're consistent, you'll get the same right answer. Okay, the distance up that it goes to get to its collision spot, well, it's S1. Okay, the initial speed, well, it's 21 meters per second, putting the units in suvat, but not elsewhere. The final speed, we don't actually know it. The final speed in this instance would be at the instant before it hits the other ball, but we don't know it. We don't know it, so it's not important. The acceleration, well, we do know that. It's negative 9.8 meters per second squared. Negative because I said up was positive. And time, we don't know that. Now, we're after S1, right? That is our final answer, yeah? Now, we can't actually get it, though, because if you look at the question, my lovelies, if you check this question out, there's only two real hard facts in it. We only know U and A. You need 3 to make suvat work. It takes 3 bits of information because all the suvat equations have 4 variables in them, so you need 3 of them to get an answer. So we're stuck. Oh dear. Unless we consider another ball. Yeah, let's do that. Let's consider ball A now. Now, with ball A, it's going down full stop, so I'm going to say down as positive on it. And let's do it. We're going to get suvat again. Suvat. All the motion's downwards, so down's a good direction to have as positive. The distance it goes this time is S2. Cool beans, buddies? U, the initial speed that it starts at, well, it's 0, actually, because it starts from rest. The final speed, we don't know. We don't actually know how fast they hit each other. A is positive 9.8 meters per second squared in this case. And T is also unknown, okay? Now here's the thing, my buddies. What you're going to find with this question here is that we're going to have to use that thing that I just said a moment ago. We are going to have to know that in order for these to crash into each other, they occupy the same space and the same time. Which means that both balls, because they both started at one, like if you push the stopwatch, we let this one go at the same time that we shot this one up. So what that means then, my folks, is that they've both been in the air for the same amount of time when they hit each other, because they both started when the motion started. Does that make sense? Which means, my buddies, that this t is equal to that t. Which means that we are going to be in a bit of a simultaneous equation situation here, and it's going to be lovely. Now, I'm seeing all sorts of nightmares playing out in my head right now of how the algebra could go on this. Worst case scenario, I'll get you a quadratic. Best case scenario, we might be able to have some fun with simultaneous equations and not have a quadratic. That'd be amazing. Okay, so anyway, V is not important in either instance, okay? So we're going to leave those out. We don't know if that's actually the same. A might be going faster than B when they hit each other, so we can't say they're equal to each other because that's not necessarily true. So let's get the suvat that doesn't have V in. Well, for ball B, here's what it is. It's S equals UT plus 1/2 AT squared. Okay, put in what we know. S1 is what we call the distance in this case. 21t plus 1/2 minus 9.8 t squared. Okay, S1 is equal to 21t minus 4.9 t squared. Cool? And I think that's as far as we can go. but at least we've got an equation that's got displacement and that's got time in it. Okay, same deal on ball B, because we don't have enough information. There's two unknowns. We're a bit scuppered here. So let's try this one. Oh, I've just found a shortcut. Let's try this one. Okay, same deal. We don't want the one with B. S equals ut plus 1/2 at squared. This time S is actually equal to S2. U is 0, which is a result, so the whole first term is 0, plus 1/2 at squared. A, 9.8, positive in this case, t squared. So S2 is equal to 4.9 t squared. I see an amazing result here. Okay, now here you go, my buddies. We have two simultaneous equations that we can work with here. Unfortunately, they're very tricky to work with because what you'd have to do is you'd have to make t the subject of this one, which means that it would be S2 over 4.9 all square rooted, which is, awful. You don't want to put that in there, do you? I don't. By God, no. I don't want to put that into there. But I spot something, though. Is there a relationship between... yeah, no, I've got an even better way still. I spot something because, okay, tell me, look at these. Look at S1 and S2, my buddies. What do you notice about S1 and S2 when you put them together? Well, yeah, it equals the whole cliff, right? So we know that, we actually know this, that S1 plus S2 is actually equal to 63. So you know what we can do? We can add these two equations together. Let's do equation 1 plus equation 2. Because if you did that, on the left, my buddies, oh, I forgot that I could scroll down. Okay, on the left, my buddies, adding on the left, you'd get S1 plus S2, if you add these two equations together, on the left. You'd get 21t, because that's not got a mate on this one, and you'd get, oh, the quadratic disappears as well, this is amazing! And you'd get minus 4.9t squared plus 4.9t squared, but buddies, that just goes, doesn't it? Because if you add them together, they're going to go, I'm going to write it, minus 4.9t squared plus 4.9t squared. That's what it looks like when you add equation 1 with equation 2, when you add the lefts together and you add the rights together. So here's what we've got, my buddies. S1 plus S2. Well, look at the picture. What's S1 plus S2 equal? Or what's that equation say? Well, S1 plus S2 is just 63, because the two of them together equal the whole cliff. Minus 4.9t and plus 4.9t just go. So you're just left with 21t. Guess what, buddies? T equals 3 seconds, which is nearly the answer. We're not quite there yet, though. T is equal to 3 seconds. So these balls hit each other after 3 seconds. Cool? Now, that's still not what the question asked us to do, but it's still useful. The balls hit each other in 3 seconds. We want to know the distance, though. We want to know what S1 is. So what are we going to do to get S1, my buddies? Well, that's it. Pop it into equation 1, and then you're done. So, into equation 1. Yeah, because we're going to get S1 then. Well, S1 is going to equal 21 times 3 minus 4.9 times 3 squared. S1 equals, let's do it, 21 times 3, take 4.9 times 9 equals 18.9 meters, which is your final answer. So how far did it go up after you let them go? Well, this one went up by 18.9 meters. That, my lovelies, is an example of a really, really, really hard question. You'll do a little bit more questions like this when you get to year 13, but as a year 12 question goes, or even as a year 13 question goes, that's a tough one. So I hope you have your head around it. I hope that it kind of makes sense. The key to it was just knowing that since they both were let go at the start, they are both in the air for the same amount of time when they hit each other, because in order for a collision to happen, two things have to occupy the same space at the same time, and that's how it worked. Cool beans? Right. Here's what you're going to do for the entire rest of the question, or rest of the lesson. Page 152, but of the mixed exercises, question 1 to 17 is just all of them, because I think that you should tailor them to how good you feel you are at them, so you should be tailoring them. But I would suggest get to the ones at the end, okay? Because the exam-y hard ones at the end are certainly worth doing. Like, maybe don't start on questions 16 and 17, but start somewhere in the 10s and kind of work your way up. See if you, yeah, just to make sure you've got a good example of proper hard exam ones. When you're all done, quick photo of it for me on to show my homework, and that's it from me. So, yeah, see you next time. Bye, buddies!